Hey guys, my name is Tomasz Rewak and today I have something different for you, well, as usually. On my screen you can see 4 grids that were created with a library called DynamicGrid. This is a library I wrote, and it's a library that allows you to create, well, low latency, high performance grid in WinForms. For some of you, WinForms might be like a blow from the past, because probably most of you have already switched to some more modern frameworks, but nevertheless WinForms still has some tricks up its sleeve, so I think it's still worth knowing. So yeah, as I've mentioned, DynamicGrid, a library created for creating high performance, low latency, very custom grids that you wouldn't be able to create with the regular data grid view. So here we have 4 examples. The first one is like a very generic grid with like column headers that you can scroll up down. There is some region that is invalidated here, well, that gets refreshed every frame here in the middle, and I will go back to this in a moment. Here we have probably, well, at least in the company that I'm actually working at, this kind of a grid is very common. So every second, or well, in this example, of course, every second, a new row is added to the top, and it pushes all of the rows beneath it one step down. And you can still scroll through this grid. If we leave with our mouse from this grid, it will just once again go to the top and just stay displaying this top line that comes in every frame. And here we have a flowing grid that every second or so randomly picks a number within a specific range and travels to this number by smooth scrolling in there. And here the selection grid, I can select some area, so it's like a very custom selection. I can see here an input being displayed, and if I type something in, it like gets propagated everywhere. If I hit enter, it will just stick here. And now I would select another region, and I will hit 4 this time, and instead of hitting enter, I'll hit plus sign. And this thing will add 4 to every single cell that got selected. So the cells that were empty have now 4 within them, and rows that had 3 are now incremented and have 7 listed in. Though yeah, this is just like an example of what you can implement with this library, though this is not like a key feature of it. The key feature is the high performance of this grid that's achieved using 2 things. One thing is double buffering using the circular buffers. And the second thing is that you can selectively select, that you can like selectively choose which columns, rows, or cells you want to invalidate. So you don't have to like invalidate the entire control, but you can only invalidate the regions that you know that require repainting. So let's first focus on those circular double buffering. And this is probably best shown in this example. So here we have 3 columns. The first one displays the index of the row. So yeah, we started with 1, it's just incrementing it. The second column is just stored the timestamp of when this row was created, and this is stored within our collection. And the third row is the timestamp for the third row is being fetched whenever this cell is being rendered. So as we can see, whenever a new row comes in, it's being rendered, but the rows that are pushed lower and lower are actually not rendered again, as we are actually storing them in the buffer, but this grid can grow indefinitely. So we wouldn't be able to allocate the buffer for every single row in existence that we might need to actually display here. And so this grid will only allocate the buffer of the size of this particular view. And if we start now scrolling down, we can see by those timestamps here on the right that those lower rows actually got re-rendered. So they got rendered again. And now if I scroll up, also those rows get rendered again. We can see this, what's going on in here, actually on this perfect diagram drawn in MS Paint, of course, because that's the best application for those kinds of things. And let's say that this is like the data that we want to display, and this is our buffer. And this is the size of the screen. Of course, the buffer has to be a little bit bigger than the screen, because it might be that we will be like in a position like this. So it might need to display this row that it's a little bit visible on the bottom, but not the entire row, and the same thing on the top. So in general, the height of this buffer has to be a height of the screen divided by the height of a row plus 2 just for those extra 2 rows. So let's say that we are starting to draw from here. Let me change the color to orange. The first row comes in, it gets displayed here. The second row goes here, etc., etc. So this is like the usual way of painting. But if now the screen actually by scrolling moves down and this extra cell gets visible, it will be drawn in here. But why can we actually draw it here? Because this cell actually goes out of the view. So this part of the buffer is no longer in use. So we can take this row and actually draw it here. And if we progress the buffer lower and lower, those new rows that get like into the view will start replacing the rows, the rows that were in this buffer before them. So this is a pretty neat trick, which allows us to display this data, to draw this data only for to draw those rows only whenever they appear. But if the data within them does not change, we don't have to actually invalidate them. So instead of like invalidating the entire view, we can only invalidate this particular section of it. It has one thing that one has to actually remember about. So whenever we want to actually flash this double buffer on the screen, we have to do it in 2 steps. So first we have to copy this part and render it on the screen with a specific offset just to adjust for this smooth scrolling if it's applicable. And then we take this second part of the buffer and display it beneath the first one. And then we have like the continuous section of the displayed view. And then they actually follow the correct ordering of those rows, which is pretty neat because we don't have to like take every single row and copy them to our to our view, but we can do this in just 2 steps, no matter how big is this buffer and how big is our screen. The thing gets a little bit more complicated in situations like this when you have different rows. Not different rows, but different columns, because with columns can have different sizes. So with this, you probably had guessed that calculating the placement of the row is a relatively simple operation, because you just have to take a modulo of the index that it would get in the continuous buffer versus this buffer that we allocated just for storing this data. So we just do the modulo operation and find out the final index. It's not possible with columns because columns can have different widths, so we have to be a little bit smarter. So I went with a heuristic that tries, it of course doesn't allocate the buffer as wide as the entire sum of all widths of columns, because that might be a lot if you, for example, want to allocate 200 columns or so. So it starts with the beginning of the screen. This is the 0. and starts drawing those rows in particular sections. But if it finds out that the column that would have been moved to the beginning of the buffer would overlap with the next one, to the first one that is still visible, it will shift it a little bit to the left and start a little bit earlier. And then it will continue like this, so once this column stops being visible, it can once again start allocating the rendering space in here. Of course, we do not do this on every rendering cycle. This is actually being pre-calculated once every time the column widths actually change, or the size of the window changes, and we pre-calculate it, and then we have just a lookup table from which we get those cropped indices where this data is being drawn. So yeah, this is how the buffer works. And on top of that, the grid itself follows the invalidate, update, refresh pattern of the Windows forms. If you are familiar with Windows forms, you probably will know what I'm talking about. So Windows forms for general controls allow you to specify a rectangle or multiple rectangles within which the data is invalid, the displaying data, so something that has to be rendered, and then with a single update call, the special onPaint method will be called, and this onPaint method will have to draw only this part of the screen. So you don't have to redraw the entire screen on every cycle or on every invalidation, but it can smartly tell the framework which parts of the screen have to actually be changed. So I replicated this, but for the part of the data side here. So a user can say that, okay, and in this case, if I'm not mistaken, I think that I say that this cell and this cell, or this cell and this cell are invalid on every frame, and then I call a refresh method, and this region here gets invalidated. If we scroll down a little bit, we'll see it happening. Okay, so that was this cell and this cell. This cell stopped being visible, and so now the grid only has to actually refresh this thing. Once I scrolled up, it will invalidate. Once I invalidate those two separate regions, it will overlay those two regions with one big rectangle and invalidate all of the data within it. Of course, this is not the most efficient way to actually invalidate those two cells. So if we want to, we can actually go to this colorful grid in here and update the data directly after both of those invalidations. Let me just refresh it. And of course, compile it again. And now we can see that those two cells actually get rendered individually because I invalidated them using the specific coordinates. But if you, for example, want to invalidate entire rectangles that overlap each other and do multiple of those invalidations in a single processing operation or something like this, then those rectangles might have some overlapping areas which you don't want to actually fetch data for multiple times, or you don't want to render them multiple times. And then this invalidate and update pattern actually is very useful. It's also being used during scrolling. So whenever I scroll, it will actually also call this invalidation on this particular row that appears on the screen. So that's why, yeah, you can see that those cells use some kind of a gradient that is being decided based on the timestamp of when this row is being rendered. And then if I start scrolling, those new rows will appear again, or for the first time, and a new gradient will be chosen for them. But for those cells that are already visible, those are not being rendered again. They are just static, stored within this buffer within this display buffer that is rotating, so it's a circular display buffer, so we don't have to worry about allocating more resources whenever a user is scrolling or something like this. Another neat trick here is actually also that between this display buffer and the data that the user provides, there is another buffer that stores what the grid knows the previous state of a cell was. So if we have cells that do not change that often, so let's say that would be just some static name of a row, and this column gets invalidated because, for example, we are lazy and we don't want to actually check which data has changed and just want to invalidate the entire grid because we think that it's relatively dynamic. And if the grid sees that this data, actually this cell did not change, that it will not invalidate, then it will not call another draw operation on it. So it's simply what it does. We can look at the code. We'll go through this code actually in a little bit. So it gets the, is it this function or not? I think it is. Yeah. So it tries to update the cell. It gets this cell struct that contains all of the information about the content of the cell and its layout, and it compares it with the cell buffer, tries to set it, and if it's the same, if it didn't change, so all the properties of the cell are the same as before, it will not call any draw operations or any rendering operations, because those are, well, relatively expensive as compared to just checking if this cell changed or not. So this is a pretty neat optimization as well. And thanks to this, if you want to, you can even like do the refresh rate for every frame, so 60 times a second, not worrying that you are going to overflow your CPU or GPU, because as you can see, this grid has a relatively low impact on the machine itself when it comes to the performance. Oh, and maybe one thing, yeah, let's think about what to start with. Maybe first I will show you on how to use this grid actually with your own implementations, which will be the good example. Let's start with the colorful grid, because it has the most data there. And this is the colorful grid. Yeah, so to implement a grid using the dynamic grid library, you simply have to inherit from the grid class. That's from the dynamic grid library, of course. And then you have to override the getCell method that returns this cell struct that I've mentioned before. And this getCell method will be called with a row index and the column index whenever a data was invalidated and it needs refreshing, or rather whenever you call the update method and there is some invalid region within your grid. And based on this row index and column index, you can decide what to actually print within this cell. This is actually relatively good design. Well, yeah, I of course will say that this is a good design if I wrote it, but there is a reason for it, because if we look at this ticker form, so this one, which pushes a row to the top of the screen, we can take a look at how it's actually implemented. So it's a ticker grid here. And usually what we would have to do if the grid itself enforces a collection that we are using for storing data on here, what you would need would be to push the first row to the top. If it was like a list or something, every time you push a new row, you would have to like move all of the element beneath this new row one row further. So it would be like an ON operation to push every single row in there. And here we are free to choose any single collection for storing data. We can like omit even this collection if we are like generating the data based on those indices. That's also okay. But here I'm storing the data, those timestamps visible in the middle row in a list. But instead of pushing the new element to the top of the list, to the index 0, I'm actually adding this item, this new item to the end of the list. And then whenever a row is requested, I simply negate this row index and use this item index to actually fetch the data. And also whenever a new item comes in, so whenever this step method is actually code, which is performed every second, though it's actually done 60 times per every second. Sorry, I was thinking about something else. So whenever this item is being added and we are already snapped to the top, so the user is not scrolling to view the data that was added in the past, then we simply move the vertical offset by the row height to the top so that it scrolls up with every new cell that actually comes in. And here we just override some default control methods just to allow for this interaction with scrolling and whatnot. Unfortunately, as I've mentioned, this is a grid rendering engine, so it doesn't provide things like functionalities like column manipulation or text insertion. So all things, for example, in this selection grid have to be implemented separately, or even a better example is with this colorful grid with those columns. Those columns are actually not part of this dynamic grid itself. This is actually a data grid view displayed at the top of the screen, simply with no data, and this is being used only to convey the column length, the column widths, and is being plugged into this grid. So whenever those columns widths change, there is an event that listens to those changes and applies the same column widths to this grid. As same thing goes for this horizontal scrolling. So it's just a vertical scroll bar put beneath the grid so that an event is listened to whenever this changes. We change the vertical offset of this grid. Oh, and this is actually a very important thing to know. So whenever you want to scroll through this grid, it's important to use those built-in properties of the grid, the vertical scroll offset and the horizontal scroll offset, because then the grid can actually decide on what should be the buffer size here and where within this buffer the data should be rendered. Because if you would put it into the big container with its own scroll bar, then the grid would think that it's bigger than what is actually being displayed, and it wouldn't be able to like cleverly omit rendering and fetching the data that is not visible. So this is something worth remembering. Yeah, and going back to the grid interactions, this selection grid is also a good example. So here we just listen to the events actually provided by the grid itself. So it provides events like on cell clicked, or other virtual methods that also translate into events, or on cell double clicked, on mouse down over a cell, things like this. We can listen to those events, and then here we listen to the event code on mouse down over cell. And whenever a user clicks on a cell, if there is no selection yet, we move the text box that we are managing ourselves to this position. We make it visible so that the user can actually insert text there and add this particular cell to our collection of selected cells. So this is just some kind of a hash set. And we also invalidate this cell to make sure that the highlight that we are displaying is also actually being rendered. And thanks to this, we get this functionality of just drawing different things with the selection and being able to actually provide the data there. So whenever a user, for example, clicks, inserts some value, so there should be some kind of an onText changed method here, we invalidate the entire selection, just clearly like this. And then whenever a cell is drawn, if it's part of the selection, so if it's selected, we are actually drawing this text from the text box within this cell. So that's why whenever I start typing after selecting after making the selection, all of a sudden this new value would appear in all of those cells. It might be relatively difficult to implement with the data grid view, especially with those infinite scrollings and stuff. Well, the infinite scrolling actually for the data grid view is possible because it has this virtual mode. But yeah, having this like wrapped up like this might be difficult with those generic controls. Though, as you have seen, those controls require some manual labor. So you have to like implement those events manually, the scrolling, you have to use separate controls for columns, for scroll bars. So if you are just aiming for creating some nice data display functionality for your application, I would definitely not recommend you using the DynamicGrid. But if you want something that performs well, and yeah, for those very high performance scenarios, then I would at least recommend you checking it out. Yeah, so maybe let's take a look also at other stuff here. So neat thing, well, oh yeah, this onPaint method, we'll skip this part, but this part actually relates to what I was talking about in this example with the buffer, only that instead of having just rows, we also have those columns. So instead of copying the data in 2 steps, we actually have to do it in 4 steps. And so if we want to render the top left corner of the screen, so the data from the top left of the screen, we have to actually use the bottom right corner of the buffer. And same goes for like top right corner of the screen relates to the bottom left corner of our buffer. With rows, it's like simple because we can like calculate the modulo operation, but with columns it's a little bit more difficult, and also there is like there might be a little bit of space in between those columns whenever we are rendering it in the buffer, at least between those 2 sectors. So we have to be clever about calculating the actual position from which we actually have to copy this data into the resulting buffer. And when it comes to those invalidating operations, those are actually extremely cheap. So let's say that we want to invalidate the row. We check which columns are actually visible and invalidate a rectangle of this row from the first column to the last column. And this invalidation method for the rectangle simply calculates a union of the previous invalidation region and the new one. So you can code how many operations like this you want to, and then you code the update method, which is on the other hand quite expensive, or can be quite expensive because it has to fetch this data for every invalidated cell. So you might not want to do it so often. Interesting stuff is that I actually use rectangle utils here just to check if the rectangles here have 0 width or height, because the standard rectangle union actually doesn't handle this scenario that well. So that's a side note, I guess, or something like that. Another thing with the managing, I don't know if I've mentioned it already, with managing of the resources. So whenever we are actually rendering cells, we here use the struct call cell rendering context. And so if we are rendering cells that, for example, multiple cells, one after the other, have the same background color, we don't actually have to switch the color that we are using. So we don't have to make a call to the GDI, because the GDI is what is being used, GDI32, for drawing operations. So this also saves a little bit of like CPU power when it comes to rendering of this stuff. And when it comes to drawing of cells themselves, I'm using the ext text out method of the GDI32 DLL. And this call is relatively simple, so we just have to provide a rectangle in which we want to display the data, and the a string with a proper alignment, so what we want to display and in what manner do we want it to be displayed. Nice thing about this call is that it also actually fills out the background color for the text we are drawing, or at least we can ask it to do it. And so this single call is also being used for drawing the background color of our cells, which is nice because, first of all, we don't have to do two separate calls, but yeah, that wouldn't be such a problem. But also it actually accepts a color instead of a brush. So we can actually fill this background with a solid color represented as a number. So with this example here where we have like dynamic gradients, we would have to dynamically allocate those brushes just for drawing of those backgrounds. And with this call, we can do it with not only with one call only, but also we can skip the step of allocating and maybe deallocating later on the brushes that we would have to use just for this operation. Let me take a look at other parts of the code that might be interesting here. Oh yeah, and also whenever the data is updated, it also collects the information on which cells have indeed changed. And for rectangle surrounding those cells that have changed, it invalidates the actual display region of the control. And then this invalidate method will result in the onPaint being called for the control and flashing the buffer, also only for the region that has actually changed. Yeah, so this is the implementation of the grid itself. It's not that big. So we have just in two separate classes the display buffer, which is just a management of the resources for the circular display buffer. And there is a cell buffer that is simply a wrapper for the array of cells, which store the current state of the grid so that we don't have to re-render the cells that have already been rendered and didn't change between invalidations. When it comes to the cell, yeah, currently it provides only some basic properties here, so text alignment, font style, background color, and foreground color. It wouldn't be that difficult to also implement things like borders, because we could just display a cell within a cell with a particular margin. But yeah, it's like limited when compared to proper grid rendering frameworks. So this only can be used for like very specific use cases. So it's definitely not like a very general use grid rendering engine, just for those low latency, high performance kind of things. And yeah, just looking at this very short repository, I think this is more or less it. If you have any questions, feel free to ask. I will post a link to the repository with this code in the description of this movie. So yeah, I hope you enjoyed this short journey through this DynamicGrid library, and see you in the next video.